In today's video lecture, we will see the ROC curve, which we called as the receiver operating characteristics, and it's a valuable tool to compare the different classifier that can assign a score to their predictions. Okay, so here it's very useful to compare the different classifiers like support vector machine, then navy bias. These are the various classifiers. Okay, this classifier assigns the score to their predictions, right? So that predictions can score or the prediction can be compared using this ROC curve, and which will be useful to identify which classifier is best for the model. Okay, so in general, what this score will do, it can interpret it as the probability. So it is bounded between the 0 and 1, as the probability range starts from 0 and ends on the 1, right? The plane is structured in the following figure like this. On the x-axis, on the y-axis true positive rate is considered, and on the y-axis false positive rate is considered. On the x-axis false positive rate is considered, and on the y-axis true positive rate is considered. So true positive can be called as the sensitivity, and false positive can be called as the specificity. Okay, so and the dash line, dotted line, dash line, oblique line, which we called it as the random performances. Now which performance is the better and which is the less worst, that we will see from this figure. Okay, so whatever the samples comes or whatever the score come under random performance and above that, that will be the good, right, better performances, right, and below that is the worst performances. That is explained over here. The x-axis represent increasing false positive rate and the y-axis represent the true positive rate, right, and dashes oblique line represent a perfectly random classifier, right. So all the curves below this threshold perform worst than a random choice, as we see, right. So while the ones above it shows the better performances, right. So of course the best classifier has an ROC curve split into the segment. First is the 0 0 and 0 1, and second is the 0 0 and 0 1 and 1 1. And our goal is to find algorithm whose performance should be as closely positive as to this limit, right. So this can be shown using the scikit-learn for the Python, where we are going to train a model to determine the score for the predictions. ठीक है, क्योंकि we require the score for prediction, right. So for that we have to train the model to find out the score of for the predictions. This can be achieved using the decision function or the predict probability methods of scikit-learn. So this is how it can be captured. Xtrain, xtest, ytrain, ytest is equals to 10 trace split. This we have already seen. We are dividing the data samples of the data set into the training and testing data set using this function with the test size of 0.25, means 75 will be the training data set. 75% data of the data set we are considering for the training purpose, and 25 we are considering for the testing purpose. LR is equals to logistic regression we are considering, and we are fitting that logistic regression model into this data set, that is xtrain, ytrain. So these are the various parameters of that logistic regression. After that we have to find out the score. So y score is equals to decision function on the x test, right. So we can compute the ROC curve using this. So here we have calculated the score. Now we have to plot the ROC curve. So using this we are calculating the ROC curve. So it's also useful to compute the area under curve, that is AUC, so whose value is bounded between 0 and 1. 0 means worst performance and 1 means the best performance. In area under curve means whatever the area comes under that ROC curve, that is the area under curve, with a perfectly random value corresponds to 0.5. So this can be done using the AUC, FPR, TPR. So this value can be calculated as this. So it's we already know that our performance are rather good because the AUC is close to 1. Now we can plot the ROC curve using the matplotlib. As this book is not dedicated to this powerful framework, I am going to use a snippet that can found in several examples. So this is the example, because in computer we are not using matplotlib, which can be used in the mechanical and all. So here we can use this code for doing that. So import matplotlib .pyplot as plt. So here we are plotting the figure of size 8 by 8. This is the plot where which model we are using, that we have to consider, and here we have to define the coordinates of that and the color, lifestyle and all. Now in x limit and y x axis limit and y axis limit we have to define. Then title we are giving, x label and y label means x axis label, y axis label we are giving. Then it is legend to lower right and show, we are showing that. So this is how it will be shown. Okay. So as confirmed by the AUC, ROC curve shows very good performance. As we saw, AUC is what? 0.97 means it's close to 1. That's why our ROC curves gives us a very good performance. In later chapter, we are going to use the ROC curve to visually compare different algorithms. As an exercise, you can try different parameters of the same model and plot all the ROC curves. हमने जो पैरामीटर कंसिडर किए वो छोड़ के आप दूसरे पैरामीटर्स लेके सेम ROC कर्व्स आप प्लॉट कर सकते हो टू इमीडिएटली अंडरस्टैंड विच सेटिंग इज़ प्रेफरेबल, कौन सी सेटिंग अच्छी रहेगी वो जानने के लिए. सो दिस इज़ ऑल अबाउट द ROC कर्व.